Alright, so in this video I'm going to teach you how to do a dilation, and this one specifically is going to be around our origin. So a dilation is a transformation that produces a figure that is the same shape as the original but not the same size. So you guys have actually done dilations all the time. Like, think about on the computer, on PowerPoint or Microsoft Word. When you insert a picture and you want to make it bigger or smaller, you drag it from the corner, right, of the picture, like the box that comes up, and you drag it from the corner to make it bigger. You do that because you want the width to increase and the length. You don't want it to drag it from just the side because it kind of looks fatter or like really squished. So you always grab the corner and you drag. You guys do that because you want it to be a dilation. You want the width and the height to increase proportionally or the same amount. Okay, so we are gonna practice one of these. So here's our graph that we're gonna use on this one. And our first question says, dilate triangle ABC by a scale factor of 3. That means I want it to be 3 times bigger from the origin. Now, you guys in my class should know that the origin means 0, 0. We've talked about that quite a bit. So our origin is actually 0, 0. So I'm going to put a dot at our origin to help us remember. So we are dilating it from here, and I want it to be 3 times as big. So I'm going to do this one by using a method called repeated translations. Okay, so I start at 0, 0, and I'm going to just count to A. To get to A, I went over 2, up 1. Okay, so A is over 2, up 1, right? I'm going to just write the coordinates, over 2, up 1. I want to do that 3 times because, again, my scale factor is 3. That is where I got 3 from. That is my scale factor. So to dilate point A, I'm going to go over 2, up 1, and I'm going to do that 3 different times. Okay, so let's look at it. So if I start here, I go over 2, up 1, over 2, up 1, over 2, up 1. So my point is going to be right here. I went over 2, up 1, 3 different times. So that is A prime. Okay? And now let's look at point B. To get to B, I went over 2, up 4. So to get to B, I went over 2, up 4. And again, I'm going to do that 3 different times because my scale factor is 3. From my center of dilation, which is my origin, you do not start at your point. You start at your center of dilation always. So to get to B, I go over 2, up 4, over 2, up 1, 2, 3, 4, over 2, up 1, 2, 3, 4. So it looks like B prime is going to be right there. Okay? And then my last point is C. To get to C from my center of dilation, which is my origin, I go over 6, up 1. Up 1. And I'm going to do that 3 times. Over 6, up 1. Over 6, up 1. Over 1, 2, 3, 4, 5, 6. And up 1. So C prime has moved right there. Okay, now I'm just going to connect my dots. I'm going to do this one in orange so you guys can see that. Alrighty, connecting my dots. Oops, that's not perfect, but it's close, so it's okay. Alright, so my triangle got 3 times bigger. Each side is 3 times as big. Okay, the area it covers is going to be 3 times as big, and it is 3 times the distance from my center of dilation, which is my origin. So A is 1, then 2, and then 3. Do you see how that distance increased also? 3 times as big. Okay? Alright, so if I want to look at this, I do want to compare coordinates. So these are my original coordinates, right? So let's look at A prime. For A prime, my coordinates are now 6, 3. For B prime, My coordinates are now 6, 12. And for C prime, my coordinates right here are now 18, 3. So if we look at our originals, A to A prime, do you see how I just multiplied each coordinate by 3? 2 times 3 is 6, and 3 times 1 is 3. So on this one, all I did was I multiplied my original coordinates by 3, which is my scale factor. So the rule you could say is when you're dilating around the origin, you multiply your original coordinates by 3.